Welcome back to The Farmer Was Replaced, the Python farming automation game. I've devised a 3-phase plan to make our farm radically more efficient and versatile, and we're going to start implementing that plan today. But first, let's address a couple of comments from last time. Diego gave me the heads up that we can plant right after harvesting rather than traversing the grid in 2 passes, which will give our crops more time to grow and reduce downtime. So let's go ahead and implement that. So here we have our plant and harvest function, which takes in the target ground type, seed item and entity to plant. We saw last time that this was quite versatile because we could easily specialize our farm to one specific crop type. As an example for how this is used, I can change this plant and harvest call from the one that's currently creating carrots to one that will plant bushes, which will give us wood. Now the problem with our plant and harvest function is that we have 2 different calls to traverse farm. It looks like we've got 5 calls to traverse farm, but we've really only got 2 that matter. The first one sets the ground type, which we only do once at the very beginning, and we have 2 different branches of the if statement, depending on whether the seed item is none or not. We want to merge these 2 traverse farm methods so that we can just call them with one function. Let's make our lives easier by calling the clear function at the top of plant and harvest. This is going to ensure that the farm is completely reset before we begin the rest of the function. Now, like I say, the main goal is to merge together these 2 usages of traverse farm. So we need one function that we can pass in here that does both the planting and the harvesting. So on the first pass through the grid, there'll be nothing planted, so we need to plant first, and then after that we always want to harvest and plant together. So let's get ourselves our plant function, which is one of these, a create plant function. And then let's create a compound planting harvest function. And what the planting harvest function is going to do is it's going to call the plant function, which will plant whatever we need to plant. And then it will call waiting harvest. So now we want to traverse the farm once to plant. And then forever after that, we want to traverse the farm, but with a planting harvest instead. This isn't going to work for crops that need seeds just yet, so let's test it with the bush and see what happens. So it traverses the farm once and plants. And then the second time it's waiting to harvest. But it didn't plant. That's because the planting harvest needs to go in the opposite direction. So let's stop this and swap around the waiting harvest with the plant function. So the first traversal we plant, and then the next traversal we're waiting, and then we harvest and plant. So as you can see, this is already way more efficient because on the second pass through the grid, we're basically harvesting immediately. So let's start worrying about the seeds now. And I think the right thing to do here is to extend our planting function to purchase seeds just in time. What we were doing before was purchasing enough seeds for the entire grid. Now, what we're going to do is purchase the seed right before we need to plant it. Let's remove this code that we don't need anymore. So the planting function is going to need a potentially optional seed item. If the seed item is not none, which in this game is not equal to none, then we need to purchase it. So what's our method? Purchase up to seed item 1. And this is going to purchase 1 seed item, but if we already have a bunch of seeds, then it's not going to purchase more. So this should now work for carrots, and you see we've currently got 0 carrot seeds. So this is a great opportunity to test. Let's try planting and harvesting with carrots. We're setting the ground type that we need to. Error. We're not actually passing in the seed item. So let's pass the seed item through right here. So the first time around we till the soil. Second time around we're planting and we're purchasing the seeds just in time. And then every subsequent time we'll be waiting to harvest and then immediately planting again. Now you'll notice that that's still a little inefficient when we first start because we traverse the grid once to till and then once again to plant for the first time. But what really matters in situations like this is the long running performance. We pay this cost once up front and it costs us 1 or 2 traversals, but then after that we're super efficient from then on. So I'm pretty happy with the solution. And thank you, Diego, very much for the heads up. Soken also pointed out that we can move to the origin more quickly by going off the edge of the grid. So you see when we're traversing the farm, we're already using the knowledge that the grid is a torus, so you can go off the top edge to come back to the bottom, but we don't use that right at the end. To traverse from the top right corner to the beginning, we're wasting a little bit of time when we could actually move directly to jail without passing go. So we want to change this move to origin function so that it can move east if we're far enough along to the east of the grid. So while the position is greater than 0, we want to say if get posx is greater than get world size divided by 2, And whenever I write functions like this, I'm starting to think like, oh, okay, what happens on the boundaries? What happens if the grid is an even length? What happens if the grid is an odd length? What I like to do is just sort of write out the shape of the logic and then go back and figure out whether I need to put in a -1 or I need to round an integer or something like that. So the shape of the logic is that if we're far enough to the east of the grid, then we want to continue moving east. Otherwise, we want to move west. And the sort of thing that can go wrong here is I could imagine us on the boundary, it's possible that we might end up moving east and then west back and forth if we're not careful. Or we might be trying to move east even if we're only in, say, the second position, so in the second column here. But this is the right shape. And then the same thing with move pos y, we're going to need exactly the same sort of logic. So let's try move to origin. Let's create ourselves another little scratch pad so we can test this. We could test it with our main plant and harvest function, but it's easier to test things in isolation. Sort of like a little unit test. So here, what do I expect to happen when I call move to origin? We're in this position, so we should be moving west 1 and then north twice. So let's see what happens. So excuse one step of the code. Maybe this is a good time to use this. So we're in here. Oh, that's a lot of little steps. So we want to be moving west, which we did. And then we're not in this branch anymore. So now we're looking at this and we should be moving north. Ah, we still move south. Okay. We thought that we wanted to move north, but actually in this case, if we move south, it takes us 2 steps to get to the origin, and if we move north, it takes us 2 steps as well. So we're actually indifferent on this coordinate about whether we move south or north. It does make me just pause and say, let's check that this function still works when we have an odd size grid. Say our grid size is 5. We're going to have pos y returning 0, 1, 2, 3, or 4, and get world size returning 5, which means get world size divided by 2 is either going to be 2 if this is integer division, or 2.5 if it's floating point division. In Python, I believe that this would be 2 because get world size would return an integer. But in this game, I'm not so sure. Okay. All numbers in this game are floating point numbers, so all arithmetic operators are floating point operators. So in this case, this is going to return 2.5, but we could use 2 forward slashes to floor the number after the division if we wanted to. But let's see what we want. So in the case where the world has size 5, we're going to want 0, 1, and 2 to move south, and then 3 and 4 to move north. So actually the fact that this is going to return a floating point is perfect for us because 2.5 is going to be great. So all that to say that I think this function just works exactly right and we don't need to add any -1s or floor division or anything like that. But just to check that we do move off the top right of the grid rather than always move west and south, let's move ourselves to the top right. So let's move south and then let's move west. And when we call move to origin, we're going to want this to move directly to the origin by going east and then north. So let's step through this. So the first time we go east, perfect. And then the second time we move north. So thank you, Stoken. That's going to save us a little bit of time on our move to origin function. Before we move on to phase 1 of the plan to optimize our farm, let's start harvesting some wood because we're short on wood, and have a quick look at our unlocks and see if there's anything that we are eligible to unlock right away or anything we might want to target. So debugging we should probably get. So sometimes your code just doesn't work and you need to find out why. We have the print function that is actually super useful. What else we got? Benchmark and debug we can't unlock just yet, but I think benchmark's going to be a pretty exciting thing for us to get our hands on in the future. Trees we need to make a start on today. Expand we can't afford yet. Let's get plenty of speed. So phase 1 of the plan to optimize our farm is to create a framework to extend our farm to support farming multiple resources at once. Right now we're super specialized. We can only plant and harvest 1 item at a time, and that results in us getting quite imbalanced resources. It'd be nice if we could just set an objective for our farm and then have our farm automatically prioritize and deprioritize resources as appropriate. So this is the sort of thing that it'd actually be super useful to already have some of these higher level language constructs available, especially I'm thinking dictionaries. What I'd really like to use is classes or enums, but dictionaries can get us some of the way there, but we're a long way off being able to afford dictionaries. So we're going to have to find a way around that for now. And I think a reasonable target for us right now is going to be to try and keep all our resources fairly level. So instead of calling plant and harvest with these specific arguments, we are going to want to decide on the fly what to plant. So I'm going to keep this plant plant and harvest function around and use it for inspiration, but I think in reality we're going to completely replace this method with a new paradigm for traversing the farm. Let's keep our ways of calling plant and harvest around just in case we're going to need them later. So we're going to need a function that's going to decide what to plant on a cell-by-cell basis. So let's call this entity to plant. And I can imagine that down the line we'll want to pass in the X and Y coordinates to this, especially when we're thinking about planting things like trees. But for now, let's just work with carrots, bushes, and grass. So we've said that our simple algorithm is going to be the resource that we have the least of. Let's just write out the code. Like I said in the last episode, sometimes it's better just to write something that works and then worry about making it pretty afterwards. So we're going to have hay count, which is going to be num items hay, wood count, num items wood, and carrot count, which is going to be num items carrot. So we'll start with the best resource being grass and the best count being the hay count. And then we'll go through each of the other resources. And this is where something like lists would be really useful, so we could iterate through them, but for now we don't have access to those things. So we're going to simply say if the wood count is less than the best count, then the best resource is going to be bush. And eventually that's probably going to be trees. And the best count is going to be the wood count. And then we do the same thing for carrots. So this is a really simple algorithm that's going to decide the best entity to plant. And like I say, in the future, we might want to extend this to use a much more complicated algorithm. So I don't think we're going to need our plant and harvest function anymore. So let's delete this. So we're going to handle cells one by one. So we're creating this handle cell function to do the planting within that cell. Let's get the entity that we want to plant. So entity is going to be entity to plant. And we need to create our planting function. So the planting function is going to be create planting function with that entity. And then we need a seed type. So let's say get seed type for that entity. And this is where something like dictionaries again would come in handy, because instead of this being a function, it could just be a dictionary. But we don't have dictionaries at the moment. So let's create our get seed type function. So for each cell, we're going to be finding an entity to plant, and then we're going to be creating a planting function for the entity and the seed type. We also need to worry about the ground type. So in a similar way to the seed type, let's create ourselves a get ground type function. And if the entity is carrots, then we're going to want a ground type of soil. If the entity is grass, then we're going to want a ground type of turf. Otherwise, we don't care. So the ground type function is going to be create ground type function, get ground type for the entity, planting function, and then we want to call the ground type function and then call the planting function. Now this seems a little overcomplicated to me because there's a lot of indirection with all these extra functions that we're going around and creating, but let's roll with it for now and see how it goes. So now let's see what happens if we traverse the farm with this handle cell function instead of our previous methods. Before we do that, let's just clear the farm, make sure that we're working with a blank slate, and let's do this forever. So while true, traverse the farm with the handle cell. And hopefully this is going to plant carrots for a little bit, and then it's going to start planting wood, and then eventually it's going to start planting hay. Get ground type takes one argument. Have I called more than one thing get ground? Yeah, there's an inbuilt function called get ground type. So let's call this get ground type for entity. So we're planting carrots, which looks good. And we've already started planting bushes. We're planting a lot of bushes, eh? Okay, we don't actually seem to be waiting to harvest. We're just going through and planting. Okay, so this is not what we want. Handle cell right now is just doing our planting. So I think we want to traverse the farm first with handle cell. And then after that, we want to do our planting harvest idea. That feels like handle cell needs a different name. So this is going to be plant in cell. So we'll first traverse the farm, planting in the cell. And then we'll create ourselves an actual handle cell function, which is going to do a waiting harvest and then plant in the cell. And already you can see that there's potentially going to be problems if some entities take a lot longer to grow than others. So if bushes take a lot longer than carrots to grow, or vice versa, then we might want to not do the waiting harvest right away, but continue on and then come back to that cell later. But let's see what happens when we do it like this. So we're planting bushes, but this time hopefully we're going to actually get some wood. So we got some wood and now we've started planting some carrots as well. So we're planting bushes and carrots. So this is working a dream. It's pretty interesting that we're now planting more bushes than carrots. Why is that? Do carrots give us like way more resources when we get them? So we're getting 1 wood per bush at the moment, and we're getting 6 carrots per thing. So this is working great. It's working better, in fact, than if we said that specific cells were always going to be designated for specific resources, because this is constantly trying to keep our wood and carrots in check. It's not really keeping track of the things that we've already got planted. So right now we know that we've got a load of bushes planted, so we're getting wood. It's also doing an awful lot of checking on the current state of the farm. But since we're still flipping every now and again, I think it's probably fine. I'm not sure why we're tilling so much. It feels like right now everything should be tilled, right? Because we're only farming carrots and bushes, and carrots need tilled soil and bushes don't care what they're on. So why are the bushes occasionally being tilled? So let's see, this ground type function, so you can kind of see we're getting a lot of return none. So set ground type, if ground type is not equal to the target ground type, then till. Must be something fairly obvious going on that's problematic here. So, oh, if get ground type not equal to none. Okay, so this thing doesn't actually handle nuns. We also went in here, if the target ground type is none, then we do nothing. So I guess return in this case, not pass. Don't mix types and spaces. Okay. And now this should eventually till our entire grid and then keep it there until we're onto hay. Like I say, these get seed type and get ground type are basically working like dictionaries. So when we get dictionaries, we can make this more advanced. And these ground type functions and planting functions, they've been kind of useful for us, but I'm not sure whether they're slightly too complex for what we're trying to do. But anyway, this is going to eventually get our resources up to even. And with a couple of extra unlocks, we got back to even very quickly. So we're now in the position where hay and wood are tied for the least resource. So we're planting some hay and that seemed to work. And we're planting bushes on top of now turf, because bushes don't care what they're on. So everything we've done so far seems to be working. We're spending an awful lot of time though farming bushes. And we know for sure that trees are a much more efficient way of getting wood. We need to make a start on some trees. We've been putting it off for a long time. It's time to bite the bullet and farm some trees. But we know that trees work a little differently to other resources. Trees like to have some space. The growing time is doubled for each tree that's on tile directly to the north, east, west or south. So we really only want to plant trees in positions that are not adjacent to other trees. And the easiest way to do that is to use the modulo operator to only plant trees in specific cells. Like I say, my philosophy is always get it working and then worry about making it pretty. So we're going to get this working. I think it's going to ruin our perfect even split of resources a little bit, the first way I can think about doing it. But I've got a plan for that in the second 2 phases of this plan. For now, let's go ahead and implement the approach that we know works. So the first thing I want to do, I think, is I've reorganized this code a little bit. I put some of our low-level utilities up here that we can just depend on. And main is just going to be the main thing that gets executed. So that can be really small over here, because we're really just working on the entity decisions framework. Get seed type and get ground type are utilities for sure. So they go in the utilities block and we can just never look at them ever again and just trust that they work. So we need to decide what entity to plant, and this is now going to depend on the grid cell. So let's add our grid coordinates to this, and like I say, the easiest way to get this working is to only plant wood in specific coordinates. I could see this getting out of hand and we might let carrots and hay escape past wood. We can mitigate that with some unlocks maybe to make wood more efficient, make the grid a little bigger, or we can take the penalty and start planting wood next to other pieces of wood. But let's say we're only going to be interested in wood if we're on a even cell grid. So remember, this is 0 index. So this is 0, 0 in the bottom left, and then we have 0, 2. So only on even cells. So if the wood count is less than the best count and x modulo 2, so x divided by 2 is equal to 0. So that's going to be 0 for 0 and 2, and it's going to be 1 for 1 and 3 and so on. And y modulo 2 is equal to 0. Now in this game, things like less than best count might cost an operation. As I understand it, the game has 2 levels of operations. You've got operations that cost like 1, and you've got operations that cost like 200. We don't want to get obsessed with avoiding single operations, but the most efficient way to write this would probably be to put this at the end. Because in Python, and I assume in this game as well, and is short-circuiting, which means that if the first check fails, we never check the others. So we're going to skip those and move straight on to the next block of code. So this is going to say here, if we're on an even cell and the wood count is still the best, then we're going to plant some trees. So entity to plant now is going to require the X and Y coordinate. Now we have a couple of choices about how to get the X and Y coordinates to entity to plant. Obviously what we could do is we could call getPosX right here and just pass it in. But maybe in the future we're going to want to find out what to plant in a cell without being on that cell already. So I'm going to use the principle of dependency injection to make this code a little bit safer in the future when we decide to refactor this down the line. So I'm going to pass in the X and Y coordinates to plant in cell. And that means that Traverse Farm now is also going to need to pass in the X and Y coordinates to whatever it's passed here. So this is the function that we're going to call on the cell. And now we're going to be passing in the X and Y coordinates right here. In Python, I'd want to make this Traverse Farm function usable by something that either expects coordinates or doesn't expect coordinates. I'd be using the Python equivalent of reflection to look at what arguments the cell function actually expects and decide whether or not to pass them in. But we don't have that option here. But right now, we're always going to be passing in the X and Y coordinates to the cell function, so it's okay for us to pass it in right here. And the reason that it's better to pass it in here is because this is where the movement takes place. This is where we're moving. So we know for sure that the cell function is interested in the specific cell that we're currently on. So plant in cell expects an X and Y coordinates. That means our handle cell needs to, and that's going to pass them through to plant in cell. So now this seems to be working. What I'm interested in, these trees look like they're going to take a long time to grow. So it doesn't feel great to me to be waiting on top of that tree doing flips when we could be harvesting the hay. On the other hand, look, it's great that this works. So I think handle cell doesn't want to do a waiting harvest anymore. I think it wants to try and harvest, and if it does, it's going to replant. Otherwise, it's just going to move straight on. So let's do that. Instead of doing a waiting harvest, it's going to say if we can harvest, then harvest. And then go ahead and plant. Otherwise, we just move on. We just move to the next cell. Let's see what happens now. So we're skipping the trees, and this time we harvested them and replanted, which is great. So this is working beautifully for us. We are running into this problem that we suspected though, where the wood is not keeping up with the carrots and hay. So I think the quick solution to that is to get ourselves a few more tree upgrades. In the short term, this solution should work for us. In the medium term, expanding the farm is going to give us 9 spaces for trees rather than 4 spaces for trees. And in the long run, I think we need to learn more about the watering functionality because that's going to make our plants grow significantly faster. But that's a topic for another day. So I think our next goal is going to be to unlock some more crops. We've got sunflowers that we can already unlock and pumpkins, which are going to be really valuable for us because they unlock some of the higher value programming constructs. We've made our farm significantly more versatile. And if you want to see phases 2 and 3 of the master plan to create an overpowered farm, subscribe to the channel and hit the bell so you don't miss a video.